Hello again, guys. We are back for topic 12.1, dealing with congruent figures. Now, you will see that this chapter compared to last chapter, I am very much following the pace of the Pearson lessons. So please make sure that you have the Pearson lesson open at the same time that you're watching this and working through your notes. So we start by looking at our key concept. So our essential understanding here is we can determine if two figures are congruent by comparing their corresponding parts. Now that's really important to look at their corresponding parts. We're going to talk about what that is. So let's say that these two polygons are congruent. We have A, B, C, D, and then E, F, G, H. Order is extremely important here. I cannot say A, B, C, D, and then say G, F, E, H, because that wouldn't keep them in the right order. I start with AB, which means I have to start with EF. Notice the order down here, AB and EF. I then go CD, so then I would go GH, and notice that if I laid these on top of each other, I'd actually have to flip this over, but all of those points would match up in the same corresponding order. So there we go, I got that all color-coded for you now. And likewise, just like the order of the points or the angles is extremely important, that then tells us what sides and what angles would all be congruent. So since A and E are in the exact same locations, they are congruent to each other, same with BF and so on. And then we can match up each set. So if I look at the first two here, AB, I can then look at the first two EF. So I'm going to underline these for you, AB and EF. That's how we see that AB here and EF there. Same with BC to FG or CD to GH. As long as the order of your congruent statement is correct, we can then find all of these congruent parts. So please make sure you've worked through part 1 of the Pearson lesson and made it to your got it here. We have two triangles, triangle WYS and triangle MKV, and they are congruent to each other. Now when we're told that they are congruent, we assume that the order is correct, because if it's written that in the congruent statement, the order must be correct. So what we see is W is first, M is first, Y is second, K is second, and S is third, V is third. Go ahead, pause the video, and try to list out every single congruent part. So you want all congruent angles and all congruent sides. When we list out the whole thing, I often at least think of my angles first, because I can easily see it just by looking at my first angle to my first one, my second to my second, and likewise my third to my third. So you see all those angle pairs listed here, and then I like to just go one at a time. If I choose WY, then I have to look at MK. So that gives me my first set of congruent sides. If I look at YS, I have to look at KV. So YS and KV. And then if I think about my third and my first, or we here went first to third, W to S, then I go first to third, M to V. So this example is not in the lesson, but it is in your notes. So go ahead and try to think, in this truss, this is like the roofing truss for a building, what would the corresponding parts here be? Now you may think it's a little pointless or redundant, but we always start with AB being congruent to AB because it's used in both triangles, my AB here and my AB there. So we do state that AB is congruent to AB. Then we move on from there and we say this side of the roof, AC, or my first and my third, and this side of the roof, AD, my first and my third. Those have to be congruent, so there's your AC, AD. And then on the bottom here, BC must be congruent to BD, also told here, BC, my second third, BD, second third. And then I can list all the angles that are congruent to each other, and I use my 3-point angle notation for any that need the specific. So up here at angle A, there could be multiple angle A's, and there could be multiple angle B's, so I use the 3-point angle notation for those angles. Please make sure that you've worked through the second part of the Pearson lesson to make it here to this got it, where we're trying to solve for an unknown angle. Now a really easy thing to do here is to go ahead and color code it, because I know that my first will match my first, second to second, and third to third. So I make those all color coded, and then I color code what it gives me. If I know that W is 62, that's my first angle, so it would also tell me that M is 62. So another thing that I can say based off that is M must also be 62. If I know that Y is 35, well that's my green here color coded, or my second, So that also would tell me that K would then also be 35. And I'm asked for angle V, which is my third angle, or blue in my color coding. So angle V is going to be the same as our angle S right above here. So since I know two of the angles, I can figure out the third. So go ahead and try that. And here is the explanation all written out in case you have any confusion still. We find out that angle V must in fact be 83 degrees. Hopefully you've worked through section 3 of the lesson to make it to this got it problem. Pause the video and ponder this. You have to have enough information that you can prove without a doubt that they are congruent. So see what you think. Is triangle ABD congruent to CBD? One piece of information that is given to you is that AD is congruent to DC, and you know you have a shared side here. So pause the video now, come back for the answer. All right, so I kind of have this written out, not really in a paragraph proof, just an explanation of it. So your answers will probably vary, but hopefully this is the gist of it. If we look at the two triangles, we have our given that AD is congruent to DC, and then by our reflexive property of congruence, we know that DB is equal to DB, or BD to BD, whichever order you choose. But that's all that we know. We don't know any other angles. We don't know any other lengths. It looks like there's 90-degree angles down here, but we don't know that. So since we don't actually know any other information, we cannot conclude that these triangles are congruent. They might be congruent. We just cannot prove them to be congruent at this time. So our next theorem is the third angles theorem, and it relates to the fact that we know that all triangles have an angle sum of 180 degrees. So it states that if angles A and D are congruent, so my top angle and my top angle, and B and E are congruent, then C must be congruent to F. Now why is that? That's because if I know A and I know B, I really know C. So I put that down here. Same thing here. If I knew D and I knew E, I really know F. So let's say this was 30 and this was, or let's say this is 40 and this is 60. That would be 100, which leaves me with 80 left. This would have to be 40 also. This would have to be 60 also, which means F also has to be that 80. So they would be congruent. And here's the proof of that solved out in your notes for your viewing pleasure, just trying to familiarize yourselves more with proofs so that when it comes time to write them on the test, you guys are very comfortable. So we start with our given, always, and then I can set up that the measure of angle A and the measure of angle D, because we know the angles are congruent, we can then state the measures are congruent. Then I look at adding my angles up. I know that a triangle angle sum theorem tells me that all three angles will add up to 180. And then based on that, I can use the substitution property to essentially plug D, E, and F in on my right side and replace that 180. From there, I can subtract away the angles that I don't care about and get just angles C and angles F left. And because their measures are equal, that means that their angles are congruent. Please work through part 4 of the lesson and then come back here for the got it. So if you've made it through part 4 of the lesson, please pause the video, try this on your own, write out a proof in whatever way you choose. I'm going to write out a paragraph proof, but it's up to you, whichever way you choose. I kind of like paragraph proofs better because it's more like how you have a conversation with somebody. You're explaining how to do it and why you're able to do it. So pause the video, give that a shot. All right, let's work through this problem here. I have color-coded everything that was given to you just so you can kind of match it up here in the figure so you can tell where it's at. So we start by talking about measure or angle A being congruent to angle D. We could also then state their measures are equal. But then if I look right in here at this angle, which would be ABE, and this angle here, which would be CBD, those have to be congruent because they're vertical angles. So because of vertical angles, ABE is congruent to DBC, and then AEB must be congruent to DCB because of our third angles theorem. So if I look here, that's this angle at E and this angle at C. And because 3 pairs of sides are congruent, that's all given to us. and we know congruent angles, then we know that these triangles must be congruent. Definition of congruent triangles. And one little bonus problem for you here at the end, just to make sure that you're doing all right. Go ahead and try to set this up, whether you do paragraph proof or 2-column or just do it in your head. Think about, can we prove ABC to be congruent to CDA? One thing that people will forget about is a shared side here. You know that's congruent. And we should be pretty confident at this by now, but here it is written out in paragraph proof form, proving that ABC is in fact congruent to CDA. Basically, because we know 3 sides are congruent and we know angles are congruent, we can prove the triangle is congruent. So that is all I have for you in lesson 12.1. Please make sure it all makes sense. Let me know if anything does not, and give your practice a shot, and then keep moving through the material. I will see you guys in class. Have a great day.